In example number 5, we're going to use the addition method when multiplication of one equation is required. We're going to solve the given system of equations by the addition method. First equation is 3x plus 5y equals negative 11. Second equation is x minus 2y equals positive 11. Adding these equations as presented will not eliminate a variable. However, we see that the first equation has 3x in it, and the second equation has x. So if we multiply the second equation by negative 3, then the x terms will add to 0. So what you can do here is you write down your first and your second equations, and what I recommend is to write an arrow, because what this allows is that if you make any errors beyond that, you can always go back and then see and check your work as to what you've done. And it just keeps everything organized. So in the first equation, we're not doing anything to it. We're not manipulating it. So we're just going to say the same because we know that we haven't done anything to it. So it's going to stay as 3x plus 5y equals negative 11. The second equation, what we can do is we can multiply it by negative 3. In order to do that, we have to multiply it by every single term in that equation. So negative 3 times x is negative 3x. Negative 3 times negative 2y is positive 6y. And negative 3 times 11 is negative 33. And now we're going to look at these two equations, and then we're going to add them. So when we add them together, we get negative 3x plus 3x, which is going to give you 0, plus 11y. And so now what we're going to do is then solve for y by dividing both sides by 11, because 5y plus 6y is 11y, and negative 11 plus negative 33 is negative 44. And so therefore, when we divide both sides by 11, we get y, which is equal to negative 4. Now for the last step, we're going to substitute y equal negative 4 into one of the original equations and solve for x. So we chose the first one. Again, it doesn't matter which one you choose, whether it's the first or the second one. And we're going to plug in y to be negative 4 to solve for x. So we have 3x plus 5 times negative 4 equals negative 11. 5 times negative 4 is minus 20. So we have 3x minus 20 equals negative 11. We're going to add 20 to both sides. 20 minus 11 is 9. And then divide both sides by 3, and we get x equals 3. So therefore, our x coordinate is 3, our y coordinate is negative 4. So our solution is that ordered pair, 3, negative 4. And then we can check the solution in the original second equation. So if we plug in the value of 3 and negative 4, we would get 11 equals 11, which is true. And also, if we graphed both of these lines on the graph, then we can see that it's intersecting at this point, which is 3, negative 4.